Welcome to day 4 of the Applied Digitalization for Oil and Gas course. Today we're gonna talk about secure network architecture, and we're gonna address the function specific network design and deployment, and gonna take a quick look at the digital twin concept and how it's applied and how does it differ uh, from traditional classic simulation techniques, and take a quick look at virtual reality, augmented reality, and collaborative online remote work environments. The diverse group of companies are utilizing secure network architectures to apply for standard based processes. These companies collaborate together to accelerate the development of network architecture, and they capitalize on the success factors, which include mass of end user, supply of OPAS compliant components, and committed safety integrators, and increased value capture utilizing such secure network architectures. The defense strategies and risk management that are used for digital networks include the following. First, they capitalize on security culture that has cybersecurity embedded into the corporate strategy and roadmaps. And security is engineered for. It's part of the controls and engineering in the design and the planning phase. Also, the supply chains are made harder to withstand any intrusions, and the cybersecurity is always part of the analysis and assessment when change management and technology change are implemented. And the implementation of these strategies is always accounting for resilience and long-term sustainability of the digital systems. When we talk about security culture, it is like approaching security with paramount importance, as we have achieved for safety. And technology is not the solution, it's only part of the solution. It is a multi-dimensional solution that involves multiple aspects other than technology. Technology is only part of the solution. It's an enabler rather than a maker. Also, the effective security culture is made up of educated workforce and organizational structure, an agile organizational structure as opposed to monolithic hierarchy architecture. Also, a strategy that builds and creates the suitable organizational culture that enables cybersecurity and the regulation, compliance policies and procedures that facilitate for cybersecurity, and the use of monitoring, audit, measurement, and analytical programs to allow the security technology to function to its best. Social engineering is one of the challenges that digitalization initiatives are facing. We can see here the phishing number one, and then the phishing number two, which has the definition and the details about it in this figure, as well as the impersonation, which are all components of the social engineering threat. And the definitions are clearly listed here in this figure. The engineering for security involves the utilization of security design framework with the three pillars for security. It builds in security from the early stages for both the digital information components as well as the physical analog components. It hardens the industrial control systems and process control networks. It implements robust monitoring systems for both physical and digital information anomaly detection. It has a life cycle from the design, operation, and management to allow for long-term resilience. The secure network framework involves periodic assessment, defense and layers, multiple layers, the deployment of firewalls for the industrial network, and the data and information flow models, the use of cyber physical access, the encryption, intrusion detection, and other software tools, as well as policies, regulations, compliance, and workflow processes. This is an example of the defense layers, which contains three layers for more layered protection. The industrial control system is special in that they run physical, chemical, and mechanical devices, systems, and processes. So safety is of great importance because they prevent the cyber-initiated incident. The long-lived assets, the long life cycle of this asset, which is decades and 50 plus years. And timing is very critical, the value of information and the action. If you have any intrusion or a breach for these systems, this gonna result in loss of a few of the process, the monitoring and dashboards, the control of it, and the corrupted data, which can lead to misleading decisions. In the event of anomalies, devices are added or removed off a schedule depending on the case, and unapproved softwares are added to the system, and the new accounts and the privileges are changed, and the rules changed for firewalls and routers. The top three threats or the nature of attacks include externals, which are, for instance, advanced persistence threats, and internal threats from internal employees or contractors or subcontractors, or accidental human error. To make the supply chain harder, it's important to assess the risk, mitigate those risks with combination of technologies, tools, and workflow processes. Insist on monitoring and feasibility, traceability of these systems, and embed cybersecurity into the specifications of the performance and contracts, and ensure management of these contracts. Virtual reality is an enabler because it allows for more feasibility. It leverages mobile and technology, and it improves the quality of procedure execution and reduces human error because it retains the corporate knowledge, which increases the digital capital, and it keeps and records the comments and attachments and feedback for future reference. This is also a virtual visit, which shows the power of virtual reality to allow for remote collaboration and remote work and tethered workers. This is an example for a clinic visit that I have made. The main advantage here is that you can have recording of the visit to the clinic, and you can refer to the visit later on to assess what happened and keep a good historian of your assets for future reference. We can see here a analogy or between the difference between traditional simulator and digital twin. It's very clear that digital twin allows for full range of the operation all the time, as opposed to simulation, which is basically a snapshot, which is static, but here is a dynamic full history of the assets. The digital twin allows for regular model runs and built into business workflows, as opposed to traditional simulator, which attempts to answer a question. The digital twin is a single version of the truth that is used by everyone, as opposed to traditional simulators, which are isolated groups. These are some common types of digital twins that we find them applicable in the oil and gas and utilities business in general. There is a case study that talks about a digital twin for a chemical plant by Siemens. And other cases for the application of digital twin is Formula One and astronomy, which is very common. And it's believed that digital twin is going to evolve greater. That's the case study from Siemens. It can be retrieved online for a chemical plant. This is a collaborative online work environment. We can see different operators coming together on one platform with different backgrounds to help in making real-time decisions, which facilitates the operations. This is an exercise that you can carry, and you read about the references mentioned earlier about digital twin, and you list some of the lessons learned and deployment. Also, you can read this report, which is very useful and informative, which talks about the cybersecurity for upstream oil and gas. And then you can carry out an exercise about the open community that shares information on health, safety, and security, and environmental protection issues. You need to mention the main points to the human resources and how you can scale them up across the entire organization. The pillars of autonomous and remote operations are as follows. When you carry automation, you need to categorize the several manual operations as automated processes, and the use of robotic inspection for high risks. This is one of the areas where we can see autonomous is high risk areas, and the remote collaborative centers, which are cloud and edge based. as well as the application of predictive maintenance and subsea engineering throughout the full cycle, which are cloud-based sensor-intensive platforms. This is an example of a Baker Hughes robotic that is used for high-risk areas for inspection. And this is a paper. It's from the Society of Petroleum Engineers. It can be retrieved online. It talks about the innovative use of drones to improve safety on asset integrity. And this is an example of the application of drones for surveying in a complex area. This is an exercise that you can carry on from that paper that talks about drones. You can list some of the potential applications for drones in the oil field or your oil field, and develop a proposal to apply it in your current job and your current work group to capitalize on the evolution of these autonomous devices in the oil field. This is a paper by the Society of Petroleum Engineers that we have published. It addresses the function-specific design for the oil and gas industry to account for security and operational efficiency. This can be retrieved from the Society of Petroleum Engineers. And this concludes day 5.